Please share this video and the others that you are watching in my channel. Share them to your friends, your WhatsApp group. You just copy the link there, share. You go to share, copy the link, and then share to your friends, share to groups. That is the only way you can assist me, kwa sababu najua huwezi nitupea pesa, si ndio? Sasa unisaidie ku share these links, share the videos to your WhatsApp groups. Hivyo utakuwa umenisaidia. With 0.1 molar 0.1 molar solution of a monobasic acid A. So once you have had a monobasic, let me give you an example of a monobasic acid. HCl is an example of a monobasic acid. Nitric acid is an example of a monobasic acid. So that is it. And then they were provided with solution B, which was sodium hydroxide solution. Solution C, which contained 10 grams of acid C per liter of solution. So what I get from here is that this is 10 grams in 1 liter of solution C. We don't know anything about solution B. So what are you required to do? So the students were required to standardize solution B using solution A, and then determine the number of moles of sodium hydroxide that react with 1 mole of acid C. Procedure. Fill the burette with solution A using a pipette and a pipette filler. Place 25 of solution B into a 250 ml conical flask. Titrate solution B with solution A using phenolphthalein indicator and record your results in table 1 here below. So the values, the correct values were, let me give you, they were here, they were 24.0, here they were 23.9, here they were, it was 24.1. So initial, let us take 0.0 to be initial, is 0.0, and then 0.0 to be our initial. And then now let us do the arithmetic. That's a subtraction. We will get 24.0, 23.9, and then 24.1. So the next obvious question is to calculate the average. Calculate the average volume of solution A used. So solution A is the one which was in the burette. Remember, it is important for you to understand the procedure. Fill the burette with solution A. And remember, solution A is a monobasic acid from here. It is a monobasic acid like HCl, sodium, and nitric acid, N of them. So HCl, or something like HCl, because it's a monobasic, I'm just using it as an example because HCl is a monobasic. Therefore, the monobasic acid reacted with sodium hydroxide solution B. That is a neutralization reaction, and it, from me here, we know the ratio is going to be 1 to 1 because sodium hydroxide is a mono. Is a mono what? It is also a mono because sodium hydroxide is, yeah, it is a mono. It contains one hydroxide ions there. So let us go straight to do the average. 24.0 plus 23.9 plus 24.1 divided by 3. This one is going to give us an average of 25.0 centimeters cube. So remember, we are using this, calculated the average volume, calculated the number of moles of solution A in the average volume used, calculated the number of moles of solution A in the average volume used. Average for our average volume of solution A used is 25 centimeters cube. But what do we know about solution A? Let us go back to the procedure, to the what you are provided. You are provided with solution A, which is 0.1 molar. That is the enough information that we have. So that means that 0.10 capital M B, solution B, this is the number of moles. This means, implies that 0.10 is the number of moles in 1 liter centimeters cube. 1 liter is 1,000 centimeters cube. So if this is the number of moles in 1,000 centimeters cube, what will be the number of moles in 25 centimeters cube of solution A? Solution A. So we ask 25 centimeters cube would give us what? So it is 25 times 0.1 divided by 1,000, which would give us the number of moles in 25 centimeters cube of solution A, which is equal to 0.0025 moles. Calculate the number of moles of sodium hydroxide N in 25 centimeters cube of solution B. So this is something that made students to be confused a lot. So they were wondering what is N. But the question is asking calculate the number of moles of sodium hydroxide in 25 centimeters cube of solution B. So N represents the number of moles in 25. So N is just the number of moles in 25 centimeters cube of solution B. But this letter N here gives students a lot of headache, and they could not understand where N came from. Others even called me during the experiment, and they were asking whether this was a mistake or a misplaced letter. But since we don't speak, we just keep quiet. So we know the monobasic acid will react with the sodium hydroxide, and the ratio to the mole ratio equal to 1 to 1. So if this is the acid, the monobasic, and then the sodium hydroxide, the ratio is going to be 1 to 1. Why? Because it's an acid like sodium hydroxide reacting with HCl. This one is it will give you sodium hydroxide chloride plus water. So this one is the ratio is 1 to 1. That's why we are saying that this is a monobasic acid. So this is an example of a monobasic acid. Therefore, it means that the number of moles that we have calculated in Roman 2, because the ratio of A and B is 1 to 1, therefore the number of moles of B25 solution B will be equal to this number of moles, because the ratio is 1 to 1. So since the ratio is 1 to 1, moles of 25 centimeters cube solution B equal to 0.0025 moles. The ratio is 1 to 1, therefore the number of, so this number of moles you have gotten here is what was referred as N. Now calculate the number of moles of sodium hydroxide. That is that number of moles. This one is N. So that was the confusion. But number Roman 4 is that calculate the concentration of sodium hydroxide in moles per liter. Moles per liter. Moles per liter simply means calculate molality. It means calculate molality. Molality is the number of moles in 1,000 centimeters cube, because 1,000 centimeters cube is 1 liter. So we already have the number of moles in 25 here. Number of moles in 25 solution B, which is sodium hydroxide, is here. So we say if 0.0025 is the number of moles which are in 25 centimeters cube solution B, and the B is sodium hydroxide, what will be the number of moles in 1 liter 1,000 centimeters cube will contain how many moles? Because molarity, concentration in moles per liter is actually molarity. So this times this divided by this. So that one, the 1,000 times 0.0025 divided by 25. This one simply gives you 0.1. Capital M represents molarity. But the good thing is that when you don't know the units to use in paper 3, you don't have to write. You can just leave your answer 0.1 and you will score or your marks. Don't write any units that you are not sure of. If you don't know, you are supposed to write moles. If you don't know, you are supposed to write capital M representing molarity. Don't write anything, just write your answer and stop at that point. Let us go to procedure 2. Clean the puree and fill it with solution C using a pipette and a pipette filler. Place 25 centimeters cube of solution B into a 250 ml conical flask. Titrate solution B with solution C using a phenolphthalein indicator and then record the observation. So the recorded value was 16.5. That was the correct value. 16.6 and 16.5, and then the initial take it to be 0.0. This one will give us 16.5, 16.6, and then sorry, one is supposed to be 16.4. Let us use this one, 16.4. So our average now, average will be 16.5 plus 16.6 plus 16.4 and then divided by 3. This one will give us 49.5 divided by 3 and the answer is 16.5. For example, here you don't know whether you're supposed to write centimeters cube, but when they ask the average volume, always the volume is measured in cubic centimeters. Therefore, you know. If you don't know, just leave it like that instead of writing things that you don't know. But since you are a good student, just write centimeters cube. Yes, so we want to, the question is asking calculate the concentration in moles per liter of solution C, given that the relative formula of mass of acid C is 210. So we have this is relative formula mass is RFM. Is the RFM. So, but remember from we were given that. I want to show you what you are supposed to know. Solution C, how was solution C prepared? It contains 10 grams in 1 liter. So we have mass in grams per liter of solution C already. Therefore, that one is it becomes easy on how to handle this one. Therefore, here I will give you this triangle. Here write molarity. Molarity. Here we have mass in grams per liter, and here we have RFM. Concentration in moles per liter means molarity. Grams per liter. So long as it is the number of moles in 1 liter, that is concentration, then it is molarity. So the question is asking how to calculate the molarity. Say for molarity, how do you get molarity? Molarity equal to mass in grams per liter divided by RFM. RFM is here. The mass that was dissolved to form solution C was 10 grams per liter. And then RFM, it is 210 to 10. Now this one gives you 0.04 0.04766. This is 0.04766. 76. This is the number, this is the morality. Therefore, you can leave it like that or put capital M. Capital M stands for morality. So calculate the number of moles of acid C in the average volume used. Now we have the morality of solution C. Morality, which is the number of moles in 1 liter in 1,000 centimeters cube. We used 16.5. Yeah, our average, you can see here, our average was 16.5. Our average here is 16.5 of solution C used. So we ask that 1,000 centimeters cube of solution C contains 0.0476 moles. What will 16.5 centimeters cube of solution C contain? So this times C divided by this, that will give you 0.00765. That is the number of moles that were in 16.5 centimeters cube solution C. Write the ratio of moles of C to moles of sodium hydroxide N in 25 centimeters of solution B. So C, this is writing the moles of solution of the acid. This acid, now write the ratio of moles of acid C to moles. So this is the number of moles of acid C. And the moles are this. So we are going to write the ratio of C to B. But the number of moles in B, we have it from here. Because we are using moles N, moles N. And this is moles N. This is our moles N. Our moles N is here, 0.0025. So that's, we are just writing the ratio. So this one is 0.00, because it is this one, 0.7652, 0.0025. That was just writing the ratio. Determine the number of moles of sodium hydroxide that react with 1 mole of acid C. So we know acid C, this is the ratio we have, C to B, and the number of moles we have said is 0.000765 to 0.0025. But the question is asking us, determine the number of moles of sodium hydroxide, so solution B, sodium hydroxide, that react with 1 mole of acid C. So how can we make this one mole? We divide it by 0.00765, so that this one will become 1, and then divide it by here the same number, 0.00765. So this one cancels out, and we get here 1, 2, divided by this and this, you get 3 point some numbers here. Because it is a ratio, we give it our number. Therefore, 1 mole of acid C react with 3 moles of sodium hydroxide. Therefore, the answer is 3. The answer is 3. Maisha ni magumu, lakini never give up.